We're going to consider a situation in which two blocks, A and B, are suspended by a light string and then hung over a smooth pulley. Block A has a mass of 8 kilograms and block B has a mass of 5 kilograms. We want to consider what forces are acting on each of the two blocks. The weight force of A is acting downwards. This is 8G. And the weight force of B is 5G, also acting downwards. The tension in the string is constant at every point along the string, and therefore the tension T is acting on A and also on B. These two values of T are equal. Consider what happens when the system is released. So when the system is released, the heavier of the two objects, A, will accelerate downwards with an acceleration of A, shown here. And the lighter of the two objects, B, will accelerate upwards. This will be with the same acceleration, as because the string is inextensible or not stretchy, the objects will move at the same rate. Notice that we are using a double-headed arrow to show acceleration here on the diagram. This is opposed to the single arrows that we are using to show forces. As we can see here, the acceleration of A is downwards, the acceleration of B is upwards. We're going to use F equals ma on each of the blocks to find two equations which we can then solve to find T and A. Block A is travelling downwards, so we're going to take the positive direction as downwards for block A. We need to know the resultant force on A. The resultant force is the forces in the positive direction minus the forces in the negative direction. So for block A, this would be 8G minus T. This is here, this is F. MA will be 8A because the mass of A is 8. We're going to do the same for block B. Block B is travelling upwards, so we're going to take positive as upwards. Therefore, the forces will be the positive forces minus the negative forces. So in this case, we get T minus 5G. This is F, and then equals MA, which is 5A. Notice that these are the opposite way around. One of them is 8G minus T, the other is T minus 5G. We can solve these. The easiest way to solve them is to add the two rows together. This will cancel out the T and the minus T, and then rearrange to get A. If we do this, we get 2.26 meters per second squared. Once we have found A, we can then substitute this in to get T, which in this case is 60.3 newtons. Remember that G is just the constant 9.8. We're now going to consider a situation where block A is sitting on a rough horizontal surface. Remember that rough means that there is friction, and is attached to block B with a light string hanging over a smooth peg, and B is then hanging from this piece of string. Block A is accelerating away from the peg. This means there must be a force acting on block A, and in this case we are told that the thrust is 900 newtons. There is also a constant resistive force acting on A. This is from the rough horizontal surface. The constant resistive force is 350 newtons. We're first of all going to sketch the forces acting on each of the blocks, and we're going to then use this to help us calculate the mass of block B. So block A has a weight force. Note that we were already told the weight force in the question. It's 1,100 newtons. For this reason, we didn't need to use mg because we already knew what W was. A also has a normal reaction because it is on a surface. We just call that R. A is accelerating away from the peg, so we can put the acceleration up there. There is a force of 900 newtons acting on A in the direction of the acceleration. There is also a resistive force which is acting in the opposite direction to motion, of 350 newtons. Finally, there is a tension in the string. These are all of the forces acting on block A. Block B has tension in the string, and this is the same T value as is acting on A. It also has a weight force. Because we don't know the mass of B, we can just call the weight mg for now, and then calculate m later in the question. As A and B are connected by the string, if A is accelerating away from the peg, B must be accelerating upwards towards the peg. They both have the same acceleration, 0.5 meters per second squared. So, in order to use F equals ma, we need to know the mass of block A. Using W equals mg and the fact that we know that W is 1,100 and G is 9.8, we can calculate that 1,100 divided by 9.8 gives us a mass of 112.2 kilograms. We're now going to calculate the tension in the string. We're going to use F equals ma horizontally on block A. So taking the left direction as positive, as is the direction of motion, we can see that the forces in the horizontal direction, positive minus negative, will be 900 minus 350 minus T. So those three terms make up F. On the other side, we have M, which we have just calculated, times A, which we were given in the question as 0.5. We can rearrange this to calculate T. This gives us 493.9 newtons. We're now going to use this to help find the mass of block B. Again, we need to use F equals ma. We're going to take upwards as the positive direction because this is the direction that B is travelling in. F will be the forwards forces minus the backwards forces, or the positive forces minus the negative forces. So in this case, we will get T minus mg for F. So we have T minus mg equals, and then for ma, we don't know m, but we do know that a is 0.5. We found T in the first part of the question, so we can substitute that in. We also know that G is 9.8. If we rearrange this to give us an equation in terms of m, this gives us m is 48.0 kilograms. So this is the mass of block B. Now have a go at these two exercises using the examples on the previous slides to help.